take a look at the problem of the day. It says the dimensions of a rectangle are in ratio of 4 to 3. Now that doesn't mean the sides are 4 and 3. That means they're 4 to 3 ratio. We're going to have to do something with them. And the perimeter is 70 inches. Find the area of the rectangle. Oh my goodness, all sorts of stuff going on. Let's take a look at this problem. Let's analyze it out. First of all, we've got dimensions that we really don't know. We know they're in a 4 to 3 ratio, but that's important. That's important because that means, according to this, one of the dimensions is a little bit longer than the other. And that's what we got our rectangle already drawn for you here, looking good, all right? Perimeter. What is perimeter all about? It's the distance around this rectangle. It's the distance all the way around. 4 sides. Not 2, but 4. A lot of times we have a ratio problem. People just look at, oh, that 4 and the 3, and they forget. There are actually 4 sides to this rectangle. And they happen to repeat themselves. But you say, well, Ernie, what are we going to do with this 4 to 3? Well, let's talk about it. Let's talk about it here. Let's look at it. 4 to 3, that doesn't mean, what is this? It says inches, right, for perimeter. So that doesn't mean 4 inches and 3 inches. It means 4 times some value and 3 times that same value, okay? In other words, we have to multiply the 4 and the 3 by the same number. I put x there because I don't know what it is. I could have put n. I don't know what it is. I could have put y. I don't know what it is. It's a variable, all right? It just replaces a number that we're going to figure out. We're going to find it, all right? So you say, Ernie, what does that mean? That means, how about it? Since that's a little bit longer, let's call that 4x. Slide around to the right. There goes 3x. Put another 4x right here because opposite sides of a rectangle are going to have the same length. They're congruent. And don't forget my little 3x over here. So you see I have 4 sides. Now why do I want to worry about 4 sides? Because I'm talking perimeter. I have to add all 4 of those sides together. So let's play this thing out. I'm going to pick up 4x. I'm going to add on 3x. I'm going to pick up another 4x. And then, last but not least, I've got another 3x. You say, well, could we have just written 2 times 4x and 2 times 3x? You certainly could, and you could have done that in your head. But let's just go ahead and put it out that we're going to add it up and let it equal to good old 70 right there, all right? Piecing it up, piecing the pieces, pulling them together, whatever you want to call it here, we've got a lot of like terms. We've got a lot of x's that want to come together as one. And it's not going to just give us 1, it's going to actually give us 4 and 3, which gives us 7. Add another 4 and 3, that gives us 14. So we are at 14x equals 70. Now I can do some quick handy dandy division. I know 14 is going to go in there 5 times, all right? And you could divide on your calculator, or you could write out the little old good short division. You could get 5. Now you say, well, Ernie, is that the answer? Oh, heavens no, we've still got a lot of ways to go, don't we? Well, first of all, what is the 5 about? It's a number we're going to multiply 4 and 3 by. That's not how we're going to get the area. We're not going to say like 5 times 5. We're going to put a 5 in for there. That's going to give us 20. You see that? 4 times 5 gives us 20. Down here, let's put a 5 in. That's going to give us 15. And now, before we go to the next piece of the problem, guess what? This is going to give us 20 also. And back here, how about it? We got 15. I want to check, first of all, do these 4 numbers add up to give us 70 before I do the multiplication to get to the area? Because I've done a lot of stuff here. So what we did, follow with me, we picked up 4x to 3x again. We decided we needed to add all 4 sides together. And we got this crazy number 5. When we put it back in, we get 15 and 20, which, by the way, adds up to 35. That's easy. Don't have to carry much. You don't have to carry at all. Now, pull it over here. Another 35. If we double 35, which is basically what we got, 35 plus 35, it's back to 70. So that requirement is checked out. However, that's still not the answer to the problem. We've got the dimensions up, 20, 15. What we're looking for now, my friends, how do we get to the area? And area, let's see if we can drop my lower third out of there. Area equals length times width. Do we know the length? We certainly do. According to this picture, it's going to be 20. Do we know the width? I see a 15. It's the only other numbers we got. So it's going to be 20 times your 15, arithmetic time, calculator time, however you want to look at it. It's going to be 300. And dear friends, those will be square inches. Hey, don't believe me? Try 20 times 15. It will give you 300 there. So there's your final area resting place. That's a multi-step problem. Great multi-step problem and a great problem of the day to get us started off. So there you go. You have it. Whew! Lots of things going from perimeter through the ratio, finally getting to the area.